Okay, so I've made up some imaginary data for the skateboarder on the ramp, and I'm going to quickly run through how to do the analysis. So the first thing that we need to do is to plot time versus distance. So what I'm going to do is, you see I've made up the data in the chart. I've put nice titles with units so that we know what's going on. I want to plot time versus distance. So time on the x-axis, distance on the y-axis. So I'm going to hold down my shift key, and I'm going to click and drag till I've got all that data selected. Then I'm going to do Insert, Chart. I'm going to choose a scatter chart with non-connected lines. And I'm going to put that down at the bottom. All right, we'll come back and we'll fix this up in a minute. I'm going to make it so it fits on so we can see what's going on. All right. The second chart I have to make is time on the x-axis versus speed. All right, so what I'm going to do is I'm going to click somewhere else. I'm going to select the time data for the x-axis. Now to select the values in what I want for the y-axis, if I have a PC, I can hold down the control button, and then I can click and drag on that, and you can see it skips over the values in B. If you have a Mac, there's other commands to do it. I'm not sure what they are, and you have to look that up. All right, so I've got the data selected. I'm going to do Insert, Chart, Scatter, and let me fit that down over here beside the other one. I'm going to save my room up at the top for doing some of the fitting that we're going to do. All right, so now what I want to do is I want to put on some axis labels, a chart title, and then we're going to do a fit. So to put the axis labels on, I'm going to click on my data on the graph, and you can see that little plus sign has appeared here. If you have a different version of Excel, the plus sign may not appear, but up at the top you'll see that. So look at the command menu up here. When I click on chart on the chart tools appears, and under design tab there's add chart element, and I can do the adding here. So I want to add the axis titles. Okay, so I can add horizontal and vertical. Let me do it down here for both of them. All right, and you can see here, let's see, my plus sign's hidden over there. Let me get rid of it. So plus axis titles. So I've got my axis titles. Let me put them on. So I had inadvertently moved that in there. Okay, so for both of them, I've got time on the horizontal axis. So let me change that to time. And I need to put the seconds. It doesn't mean anything if it doesn't have units. So both of them are time. Okay, the y-axis for my first graph is the distance in meters. For my second graph, yeah, I'm a little bit compressed, so let me make that a little bit bigger. It's speed in meters per second. Okay, and when you do a graph, you should always take a look and make sure that your data goes over the range that you'd expect. So here I've got the times from 0 to 10, which is correct. And my speed goes from 0 to 40, which is also correct. So it looks like it makes sense. All right, let's see. I got that a little bit compressed. Let me see if I can sort of move things over a little bit, make it a little prettier. All right, chart title. I need to make a title that's not X versus Y, but tells the person who's looking at the graph something about what the experiment was. So let's say this is position of a skateboarder on the ramp. And the other one, let's see, I'm going to fit this when the slope is going to give me the acceleration. So let me say acceleration. All right, so the big thing that we're trying to do in this experiment is to show that the data in this first graph looks like equation 1, and the data in the second graph looks like equation 2, and then fit it and get values for the initial velocity and the acceleration. All right, so let's put in some writing here. So equation 1, this should fit to x equals x initial plus v0t plus 1/2 a t squared. All right, so if I fit this to a second order polynomial, my coefficient of the second order term should give me a over 2. Coefficient of the first order term should give me v0. My second one should fit to equation 2, which is this, that v is equal to v0 plus at. So that's the equation of a straight line where the slope is going to be a and the intercept is going to be v0. All right, so let's get Excel to do the fit. So there's two ways we can do it. One, if we just want to get the parameters, we can click on the data and I go to my plus, or I could go up to the top in the design tools, add chart element, trend line. And I want to pick more options. So my first one, you can see it's put on a straight line, and that's what I don't want. The default is to do linear. I want to do a polynomial to the second order. So it looks like a pretty nice fit, that line that's come on there. I'm going to display the equation on the chart. I'm going to display the r-squared value on the chart. Let me move that over away from my line so we can take a look at it. So if I look at this, my coefficient that's in front of the squared term, that's my a over 2. My coefficient in front of the linear term, that's my v0. And my coefficient, that's the constant term, that's my x0. Now we know we started the skateboarder at rest at a position 0, so you can see that these numbers aren't quite right. Okay, now we got the second one we want to fit to a straight line. So I'm going to click on it and let's go up here, chart tools, design, add element, trend line, more options. All right, this time I do want a linear, and again I want to put the equation on there and display the r-squared on there. So I want to know what the equation is and how good a fit it is. For the r-squared value, if r-squared is exactly 1, it's a perfect fit. If r-squared is very small, it's a very bad fit. So you can see for both of these, the r-squared is very close to 1, so it tells you it's a very good fit. Okay, so if I look at this one, the first term, that's my slope, which is the acceleration. And my intercept, which is v0, is negative 0.1227. And we know that should be 0, and it's not. Okay, so what we need to do is we need to know what's the uncertainty in the values for these fit. And to do that, we need to use an equation in Excel, a function called linest. So let's do the fit, and let's start off with for the linear one. So what we're going to do is we want to know the slope and the uncertainty in the slope, and we want to know the initial velocity, and which is the y-intercept, and the uncertainty in it. So I'm going to select a 2x2 array, and in the first cell I'm going to go up here, I'm going to type in the function linest, linest, open bracket, and then you can see up here it's giving prompts of what it wants you to put in. So now it wants to know the known y values. So for this one, I'm doing, remember this graph over here, the y values are the speed. So I'm going to click and drag to select it. All right, so now you can see known y's is highlighted. I'm going to put a comma, and then it jumps to say it wants the known x values. X values are time. So I'm going to click in here and drag, and you can see now it's color coding those ones red. Okay, so there are my x values. Next thing it wants to know is, and it gives you some prompts there, do I want to have the constant b, my intercept, automatically set to 0, or do I want it to fit it? I want to fit it, so I'm going to put in a 1. Okay, next function is, do I want to get back some additional regression statistics? And yes, I do, because I want to know the uncertainty in there. So I'm going to put in a 1, and I'm going to close the brackets. Now normally your reflex is to hit enter, but since I'm filling in an array, I have to do Control, Shift, and enter. And when I do it, you're going to see that it's going to put a number into each of those 4 boxes that I've highlighted. All right, so there we go. So this one here, this is my slope, and this is the uncertainty. Let me put delta, the uncertainty in the slope. All right, this one here is my intercept, and this is the uncertainty in my intercept. So by looking at these data, I can see that my slope, and my slope is the acceleration, I can see that my acceleration A is equal to 4.01. I'm going to round that off a little bit, plus or minus 0.035 meters per second squared. And my velocity, my initial velocity is the intercept. V0 is equal to minus 0.123 plus or minus 0.21. All right, so it's equal to 0 within error. All right, let me clean that up a little bit because I'm going to need to write there. All right, so there's my A and my V from this first graph, from the second graph that I did. That's the linear fit. Now I need to do my polynomial fit. So my polynomial fit, I've got three coefficients. I've got my x squared term, my x term, and my constant term. So I'm going to need to select an area that's 3 by 2. So I'm going to get the value for the x squared term and the uncertainty, value, uncertainty, value, uncertainty. And I'm going to do the linest function again. So I'm going to go up here in the function bar. I'm going to click equals linest, open brackets, and now same thing, it wants to know the known y values, and since we're doing the fit for this curve here, y values are distant, so I'm going to get those and put a comma. Then it wants the known x values. Alright, but now I want to fit it not to a straight line but to a second order polynomial. So what I'm going to do is I'm going to do the caret function. So what you'd usually do to say raise to the power. So I'm going to do that. I'm going to do a curly bracket. Then I'm going to do 1, 2. So it tells me I want to do the first order and second order. Then I'm going to close the curly bracket. So now I've filled in all my known x's. I'm going to put a comma. And then I'm going to do the same thing that I did for the other one, 1 and 1. Because I want to fit everything and I want to get my values. Close brackets, that's a regular close bracket. Then again, remember I'm going to do Control, Shift, Enter. And there I've got my values. So what are these values? Let me see, I'm going to have to write above them. So this is my x squared term. So you can see it's the same number that I have down here in the graph. So this is going to be my a over 2. This one here, that's the uncertainty in the a over 2. The second number, that's my v0. And this one is the uncertainty in the v0. And the third one is the x0. And this is the uncertainty in x0. So if I do the same thing that I did before, I get my second order term, which is a over 2, is 2.03 plus or minus 0.02 meters per second squared. My V0 is negative 0.16 plus or minus 0.24. And really and that's in meters per second. When I report the uncertainty, I really should round that just to one figure. So this one up the top, I should have said plus or minus 0.04, plus or minus 0.2, etc. All right, and let's see, x0 is 0.2 plus or minus 0.5 if I follow my rule, meters. So we expect x0 and v0 to be 0, and you can see that within uncertainty, they fall within the range of their uncertainties, they fall on 0. So that's okay. The only reason they're not 0 in the fit is because we have some error in our data. All right, so how about our acceleration values? Do they agree with each other? Well, our value from the linear graph is the acceleration is 4.01 plus or minus 0.035 meters per second squared. From our quadratic graph, polynomial graph, we get that the acceleration over 2 is 2.03. So to get the acceleration, we would multiply by 2. The acceleration is 4.06.